You remember this stuff, like today.
That up there while you just recording, so when we talk or something.
Whatever we do, like right now we're live. So yeah, whatever you say or do ends up on there too. So sometimes when we've had discussions about oddball things right in the middle of a lesson, that stuff shows up. And it is forever captured on YouTube.
You know, if people don't want to watch it.
They can fast forward me. I decide I want it real. So if people don't want to, deal with the reality of what goes on in here during the day, that's their problem. It'll be all right. Exactly. So, now, a couple of things to go back over from yesterday to make sure we've got this. We got to jot a couple things down here. Okay. First things first, since we're talking about slope, probably should realize what that is. Slope in life itself is called something else. It's called a rate of change. Now that can be speeding up when you're driving in the car. That can be the amount of money you're making on something. If you're selling something and you can increase the price and your sales go up, that can be a rate of change. So it applies in a lot of places, not just two dots on a line that we're doing in math class. But a couple of things we didn't talk about yesterday that we're going to add in, but we're also going to review some of the things we were doing then too, is that the steeper a line is, it has greater slope. Now that doesn't mean that a positive number has a greater slope than a negative number. It doesn't mean that at all. It just means when you're thinking about it, if you're like maybe riding a bicycle and you're going up a hill, you don't want to go up a hill that's like this. That would be kind of hard. It'd be better if it was like this. It's even better if it's like this because you're going downhill. But that's one of the things we're going to talk about today. And the last thing we're going to add in today is that sometimes when we have multiple lines and they never cross, those are going to be called what's called parallel. And I can do that even without a picture because the lines will have the same slope. And these are some things that aren't necessarily going to show up on the mini quiz, but they will when we get to our first regular one. So today I wanted to be a little more visual, get some slopes out there and kind of just look at some basic stuff, not all the calculating quite so much. So here, for instance, we talk about the rate of change. Now this is something we're going to review from yesterday. And I grabbed the wrong pen. Let's try this one. Rate of change, again, is just a fancy word for slope. In other words, however much I go up or down when I'm going from one point to another versus how much I'm going to go to the right or to the left. And again, it all depends on what my signs are going to end up being, but it ends up being a fraction each time. So when I start to do these, I'm not going to worry so much about this question right now because, well, it's not marked off. I want to do something a little more general first. So I'm actually going to move up here a little bit. So when we're talking about slope, we're talking about steepness, okay? So when it says the greatest slope, which one of those lines looks the steepest? Which is the one you wouldn't want to ride a bicycle up? A. Okay. So that's going to be my greatest slope. I don't really care right now if it's positive or negative. I just want to make sure the one I don't want to ride a bike up. Which one would be the easiest to ride a bike up? C. Because that's got the least slope. Just understanding some general things like that will help us when it comes to actually start calculating some of this. Now we talked a little bit yesterday, and I got to go grab my buddy here because I forgot to have him over here. Yeah, we got to get our tattooed buddy, Mr. Slope Guy, involved here. Okay. When we talk about positive and negative slope, remember, if it goes up as it goes to the right, it's a positive slope. If it goes down as it's going to the right, it's negative. So with that in mind, when I look at these, there's 4 lines here. 2 of them have a positive slope. Which 2 are they? Which 2 go up to the right? Okay. A and D both go, as I go from left to right, they're both going up. Now A is steeper, but it still has a positive slope. So then a kind of process of elimination for the other two. My other two that have negative slope, or go down as I go to the right, again, not as steep, but it's still down, would be B and C. So if I ever ask you sometime to figure out if a slope's negative or positive, that's a way I can do it. So then you're like, okay, maybe. So as we kind of keep moving down, my next set of lines never touch. So there's two things that have to be true here, and it's what we mentioned up above in our main concepts. Number one, if they don't touch, that's the definition of parallel lines. They don't touch. But what also has to be true about those is when they're parallel, they have to have the same slope, because that's why they don't touch. That's why they never cross each other, because they just keep going at the same steepness all the way through. So when I'm trying to figure these things out, one of the ways I can do it in an application is maybe my axes won't just say X and Y. They'll have like seconds and feet. So what this would be an example of is what's called a rate of change, like we mentioned up above. Oops, I'm off the screen. A rate of change. And when you're doing these, it's always my Y value over my X. In this case, my rate of change would be in how many feet I'm moving per second. This one, that'd be a lot of feet a second. I'm going straight up. That'd be kind of tricky. But my biggest thing here is just understanding it's my Y value over my X, just like it is when I do slope. It's feet per second. Real high rate, real low rate, I'm not hardly going anywhere. Okay? But our biggest thing when we're doing this, let me give myself a peek here on what I'm going to get into here on the back, is going to be just understanding some of the basics. And we're going to talk some more about some specifics too. So when I flip over, I guess I shouldn't have used a marker, it's coming through to the back. I'm going to come down to this middle part for a second though. Okay. Horizontal and vertical lines, we talked a little bit about yesterday, because again, if it's a horizontal line, add this to Mr. Slope Guy, a couple new tattoos today. Horizontal lines go side to side, like the horizon does, like where the sun comes up. And then vertical lines, I haven't seen these commercials on TV in a long time. I'm going to age myself, but Mountain Dew always used to have a commercial. They were like, get vertical with Dew. Well, that's kind of the same thing. When you go and do a jump thing here, yeah, I'm not going to be going on to any singing shows anytime soon. But that's the same idea that's working here. So when we talk about horizontal and vertical lines, there's a couple of things I can do. When I see these y equals ones, these are going to be horizontal lines. They go side to side, and their slope equals 0. So when I graph these, all I have to do to make a graph, and they're the easiest graphs there are with these. Okay, my y-axis is the one that goes up and down. I go to that value, y equals positive 6 right here, so I'm going to put a big old dot. And then I'm just going to draw a line through it. So this, bless you, this would be y equals 6. That's the line. Nothing fancy. And whatever number that y value is, okay, so it's -2. Well, negatives are down. So I put a dot. And again, it's just going to be a horizontal line if it's just y equals in a number. Nothing else to even have to think about. Now, the very first one here, okay, now that one's going to be a little bit different. Let me do these two x's, and we will come back up and we will do that one, because I will not let that one go by here. But I do want to find, there we go. Give me a red that's not going to bleed. Okay. These last two, where it's just x equals and a number, these are the vertical ones, and no, don't worry, I will not sing again. Vertical lines go up and down, and their slope is what's called undefined. Because what we'll learn is, as we go along, when we do our rise over run, the number on the bottom is 0, and I can't divide something into 0 parts. It's just not humanly possible. So for these, my x-axis is the one that goes this way. So I just find the x value. I put a big old dot. And I'm going to draw my vertical line through there. And for some reason, sometimes, these are the ones that get hard for people. I think they get so used to the regular form, I guess they just forget. But they should be the easiest ones to work with. So I see x equals and a number. I go put a dot there. And then I just draw the line through it. Now, I'm going to give you a little preview into what we're going to start getting into when we get into the next part of this unit. Because Courtney had said, well, what about that first one? You know, there's y and x here. What's the deal with this one? Well, that one's special because it's in what's called slope-intercept form. And here's how that works. If I get y and x, like I do here, I'm going to start in the middle of the graph. And this number in front of x is my slope. Now, we're not quite ready for this yet, but it kind of lets you see how this works. So if my slope is 3 over 1, yeah, I'm going to go 3 up. And since it's positive, I'm going to go 1 to the right. So I'd go up 3, 1 to the right. What's that? That's a good idea. Because as you mentioned that, I was going to connect them right away. But you're like, why would I want 3 dots? Why can't I just do 2? Because sometimes maybe that second dot you mess up on, and when you do the third one, you're like, well, wait a minute. That doesn't quite line up with the other ones. So this, and notice it's not just horizontal or vertical. It has a little bit of slant to it. Now again, we're not into this quite yet. It's just a little bit of a preview. So don't panic if you're like, wait a minute, what did he just do? No biggie. We'll get into some of that too as we go into some more with our slope. So then it just talks again about the bottom here. Slope's the same thing as rate of change. It's the steepness of our line. It's the same between any 2 points on a line. And then y equals a number is horizontal. Slope is 0, just like Mr. Slope Guy said. X equals is vertical, slope is undefined, just like Mr. Slope Guy's face says. Got it, Mr. Slope Guy. If you've lost Mr. Slope Guy, grab another one of them out of the folder, because he's going to be helpful with these. So how is he going to help us today? Well, we're going to go back, and you're like, dang, some of these are done already. I try to be helpful. So what we're going to do is we're going to practice some of the stuff like we were doing yesterday. Kind of repeat it. So reminder, okay, this is homework check 11. This is our third and last homework, and it's all 3 of them that we've done this week so far, Mondays, Tuesdays, and todays. So you still got some time even today and tomorrow and maybe part of Friday even to get this done so we can get it in and get a good start with this unit. But what I want you to remember is when we're figuring out slope, when we have a graph, and we did some of these yesterday, and you've got a note sheet for that. And again, if you don't have it, grab one out of the folder. Is I'm counting from one dot to the other. And all of these lines have my 2 dots on them. But when I'm doing it, and I put this up here as a reminder, your up or down number, how far it takes to get up or down to get from one dot to the other, we always do that first, and it goes on top. So on this one, for instance, to get from A to B, I go up and I go right. So I went up 1, 2, 3, 4. So my number on top was 4. That's where it came from. And then once I get there, to get over to the B dot, I went right. 1, 2, 3. And that's where the 3 is coming from. And that's my slope. I'm done. Okay. Nothing complicated. It goes up to the right. It's positive. That checks out. Now when I look at the next one, though, I notice something right away. It's going down to the right. So I know this one's going to be negative. So in going from A to B, again, I'm going to make myself a little triangle here out of this so I can visually see what the slope's going to be.
How do you know which side of the line?
You mean if I went this way or if I went like this? Doesn't matter. I'll get the same answer. Yep, that's the cool thing with slope. You can go in any direction you want and you'll still get to the right answer. And I'll even show you that on this one. So if I chose to go this way first, I would go down 1, 2, 3, 4, 5, 6. So down 6 is my number on top because it's always the up or down numbers up there. And then I went right 1, 2, 3, which is positive 3. And negative 6 divided by positive 3 is negative 2. And if you're not sure, of course you can always go and use a calculator. I don't care. Negative 6 divided by 3. And you're like, okay, but why do you have the over 1? Well, again, we talked about with slope, we want to make it a fraction. So when we do get to graphing more of these, it's going to be easier. But let me take Caitlin's question on. Well, what if I didn't do it that way? What if I said I'm going to go this way instead? That's okay. If I went this way instead, here's the only thing. I always have to do my up or down number first. So this time I'm going to go from B to A. So I'd go 1, 2, 3, 4, 5. I'd have a positive 6 going up, because I went up. But then I'm going to go left, 1, 2, 3. If I go left, that's negative. So if I do 6 divided by negative 3, I still get negative 2. So I still get the same answer no matter which way I go. The only thing I got to be careful of is up and down number, always on top. Left or right number's always on the bottom. But that's, again, what this is here to help you with. It's to help you figure out what signs you're going to be working with. Now 6 is the other one I want to look at up here. Because I look at 6 and I go, wait a minute. Harty, those dots are like on the same level. I mean, here they are, right, like this. How many do I have to go up or down to get from A to B? None. Okay, I don't have to go up or down at all, so 0 goes on top. Well, let's see. And then to get from A to B, I go 1, 2, 3, 4, 5. If we're not sure, 0 divided by 5 is 0. So my slope is 0 on this one. Because remember, here goes Mr. Slope Guy again. If it's a side-to-side line, if it's horizontal, my slope is going to be 0. If that line would have been up and down, if it would have been vertical, then it's undefined. But that's the cool thing with the calculator. If you're not sure if it's 0 or undefined, what you can do, thank you.
Yep.
What you can do is you punch it in the calculator like this, because if it would have been 5 divided by 0 for some reason, which it's not for this one, you're going to get an error message. Error means undefined, and that's how I'd know the difference. But again, this is basically going to be stuff we were trying out yesterday. And again, Mr. Slope Guy has the formula, but I also put it on here. When I'm doing these, and this is for any of them, I'm going to label my x's. I'm going to label my y's because x comes before y in the alphabet, and it does on these too. And then all I'm going to do, I'll put in my bar, I'm going to put in my minuses. Y's go on top. Okay, and I always just do the second one and then the first. So second one would be 5 minus 3. And then I do the same order with my x's. So since I started with the 5, I'm going to start with the 2 for x and 8. So let's see here. 5 minus 3 is 2. What's 2 minus 8? That's negative 6. Okay. Now, I need to make sure, if I can, that I reduce this. Now, if I'm not sure if I'm in simplest form, I can do 2 divided by -6. I don't want a decimal, though. So math, enter, enter. Okay, so it's -1/3, and I've got it. And I also can check, because if I'm doing things right, I should find the answer somewhere down here at the bottom. Now, do you have to do the puzzle? No. But if it lets you see that, oh, that answer's there, okay, I'll use that. I'm good with that. And that way, as you start getting towards the end, you can make sure that your answers are all there. It makes things kind of nice. Now, there's one more down here I want to do. I want to do, if I can remember which one it is, number 12. Yes, number 12. Because if I do number 12, same idea, get your bar in there, get your minuses in, because that's part of my formula. I'm going to do my y's first. And again, you can do them in either direction, but I always do the second one and then the first one. But ooh, be careful on x. Because I get to the x's and I'm like, okay, that's -4. That's -5. This minus that's here doesn't count for that negative. I still need to put the negative in here.
Can I have Adriana please go?
So if you need to on this, again, if you're comfortable dealing with positives and negatives, just do it in your head. If you're not, it's okay to punch it into the calculator. But what happens, now let's see if we can just figure this one out. What happens if you minus a negative? It does. So this will become positive, because I notice if I did -4 minus -5, if I typed it in that way, I got 1, -4 plus 5. Yeah, that's 1. I can't reduce my fraction anymore, so that's as far as I can go. Now, notice they're bad down here. They're not making their slope a fraction, but we know that -6/1. Yeah, we know that -6/1 is just going to be -6. Or I could just make all the whole numbers fractions down below. You do not have to do the puzzle at the bottom. I just think sometimes it's nice so you can make sure your answer's actually working. But yeah, you absolutely do not have to. Okay? So then when we get to the back, here's the last thing we're going to do here. When we get back here, we're just finding the slope, okay? And we're going to use the labels. Now, I'd already done number 1 here, and here's the part that gets a little more interesting. I can choose any of the 2 dots that I want. So like, for instance, here, if I just want to choose the 2 that are closest together, I can. But when I'm going up, this isn't just 1. That's what I have to be careful of. Because if I look at the labels, I'm like, oh, it's going from 40 to 80. Well, from 40 to 80, that's 40 difference. So it's up 40. And then when I go to the right, I'm going from 5 to 10. Well, the difference between 5 and 10 is 5. So I put the 5 on the bottom. So up 40, right 5, and then I can just divide that out. So like, for instance, if we were going to do that on number 2, and I can choose any 2, but let's just say I choose these. How many am I going up here in actuality? 15. So $15, because it says dollars over here. And then how many am I going to the right? If you can read the little numbers.
3.
Okay, I start at 3 here, and I'm going to 6. So I'd have 3 books. And then just divide it out. So like, for instance, here, I got 15. It would be 15 divided by 3. Yep, $5 over 1 per book. Good. So I'm just using the numbers they have there. And once we get below that, the only thing that we've got left to look at, okay, find the slope. Some answers will, well, with us, all answers will be fractions. But when I'm doing any of these, and I did one down here to try to help out, but we'll do a couple others. all those dots that are there, I can use any pair of them to get my answer. But I always like to use the two that are closest together because then I won't have to reduce the fraction. So like here, okay, going from one dot to the other, I went up 1 and right 1. It's just 1 over 1. Okay. I got the answer. That was pretty cool. That was easy. Let's find one that's not quite that easy. Like number 8, let's say. So like on number 8, I see there's 3 dots here. And I can use any pair I want. I'm just going to use these two. Make my little triangle. Now remember, my first number is my up or down. So if I'm going from this dot to here and then here, how many is it and what direction am I going? Down 2. So -2, right? Since I went down. But then I'm going right 1. So is this going to be positive or -1? Positive. And I'm good. So don't make life complicated on these. We're just counting to look over. Now, I can't answer number 13 until I've answered 5 through 12. Because, again, steepest slope, I'm going to be able to look at it and say, ooh, I don't want to ride my bike up that. It's this one. Okay? So that's all it's being asked for when we get down to 13. But I got to have all these done first. Okay? You know, don't want to ride it. Negative slope. Remember, the lines that are down to the right are going to be my negative slope. My positive slope are going to be any of the lines that go up. And then all they're asking me on the end here, 14 through 17 are, is it positive or negative? You don't have to find the slope. Just look at it, and if it's going up to the right, it's going to be positive. If it's going down to the right, it's going to be negative. You just write one word or the other. So again, this is the last one coming on this homework check. So you got about almost 15 minutes to work with here. So try to knock at least some of these out on these so you can kind of see how it's going, and maybe now you can do the one from yesterday even.